So, welcome everybody to the second WIP seminar of the year 2025-2026. Today we receive one of ours, Victoria Van Gheem, that will give us a talk to show how the evolution of her research since last year, formalizing medical reasoning, can fuzzy logic account for normativity?
Thank you for being here. First thing first, I have to introduce what I do for my thesis project. So, my thesis project is based on one observation: medical reasoning is a mess. It's due to a lot of different elements, but two that are interesting here are: first, the goal of medical reasoning is not always just do reasoning, produce knowledge, but often practical, therapeutical. So we don't always look for truth. We want to have a reasoning that leads to conclusions that are useful, not always true. And second, clinical reasoning and medical reasoning in general has to deal with very different information and has to account for all of it. For example, biological and physiological facts, individual facts about the patient, statistical facts, opinion-based and expertise elements, biomedical norms, individual norms about what is considered a desirable thing for the patient and by the patient. So there's a lot of different information going, and we have to do a bit of cleaning and how do we account for all of it. My focus is on specific information included in medical reasoning. It's norms. I will give a definition of what I mean when I talk about norms later. I'm working specifically on clinical reasoning, because medical reasoning may be a lot of different things, including reasoning that we do when we do medical research. So I'm working mainly on clinical reasoning. That means roughly diagnosis, prognosis, and the selection of a treatment for a patient. So what a physician do when they have to deal with the patient and heal a patient. The idea behind my thesis project is that I study reasoning, and logic is science of reasoning, so I'm trying to find logics or logical tools that can take into account the norms, because I suppose that they are relevant and intrinsic and embedded in medical knowledge and specifically clinical reasoning. So I'm working on logic in medicine, not logic of medicine. Logic of medicine is the idea that there is a logic, that medicine has a logic of its own, and that's not what I'm doing. I'm doing logic in medicine. I use logical systems that already exist, and I try to apply it to a specific case of medical and clinical reasoning. My hypothesis is just that logic may be a way to clarify medical reasoning. So that's my goal for the 5 next years. My goal for today is to propose to test a first logic and try to define what are norms in medicine, and can this logic account for clinical reasoning and the inclusion of norms in them. I'm using Sadegh-Zadeh's book, Handbook of Analytic Philosophy of Medicine. Sadegh-Zadeh is one German philosopher of medicine. He wrote an enormous book about many different things in philosophy of medicine, including the idea that fuzzy logic is a fitting logic for medical reasoning. So I will first explain what is fuzzy logic, why is fuzzy logic a useful tool for medicine, and then I will try to define what is normativity, what are norms in medical reasoning, and in this application of fuzzy logic to medicine, can fuzzy logic account for normative parts of medical reasoning? It's the plan for today. So, what is fuzzy logic? Fuzzy logic is a logic that has been created to deal with the vagueness problem, which is connected to the Sorites paradox. Just quickly, Sorites paradox is a paradox about vagueness, and it can be we can have different version of this with many different concepts. But the first version is with a heap of sand. So first premise, 1 billion grains of sand is a heap. Second premise, a heap of sand minus 1 grain of sand is still a heap. And then the conclusion, when 1 billion grains of sand minus 1 is still a heap. That's an application of the modus ponens. And if we repeat the application of the modus ponens, we arrive to the conclusion that 1 grain of sand is still a heap, which is a paradox because we don't want to say that 1 grain of sand is a heap of sand. So fuzzy logic is an answer to understand the notion of vagueness. And vagueness, I will use it like something is vague if we can create an example of the Sorites paradox with it. There are two different approaches of fuzzy logic, one made by engineers and one made by philosophers. They deal with the same problem, but they almost don't communicate. Sadegh-Zadeh, while being a philosopher, is using the engineering type of fuzzy logic, so I will use this one too, but I will raise at the end questions about, and what about fuzzy logic made by philosophers? So fuzzy logic by engineers is based on the fuzzy set theory, so it's a set theory that says that every set is a collection of objects with a continuum of degree of membership, which means that there are objects that are fully inside a set, there are objects that are fully outside the set, like 1 billion grains of sand is fully a heap of sand, 1 grain of sand is fully not a heap of sand, but there's a continuum of things that are more or less in the set, and to determine this we use the membership function, which is represented by the mu letter that we see here. So there's the idea. The fuzzy logic is based on this idea. To that we add variables. I will give concrete example to explain more clearly just right after that. So we have numerical variables that are not fuzzy because we have like either 1, 2, 3, 4, 5, etc. That's clear. The thing is either 1 or not 1. For example, your age, it's a clear number, but you can fuzzify those numerical variables and use linguistic variable. For example, you are 25, that's a clear numerical variable, a crisp one, but you are young, that's a linguistic variable, and it's less clear. Are you entirely young when you are 25? Are you young to the extent 0.8, 0.2? It depends who you're asking. But so that's the idea that you can fuzzify things that appear numerical and clear. Truth can be seen as a variable too, so you can have a truth value between 0 and 5, including 0 and 5, but a whole continuum of values that you can take between 0 and 1, not 0 and 5. And in fuzzy logic you also have linguistic hedges they act like semantic operators. They are words like very, quite, extremely, that permits to add granulation to the variables that you have. For example, someone is young to the extent 0.8 but is very young to the extent 0.2. You can have a more precise granulation. Fuzzy logic is this framework, but it is also a set of tools that can be applied to other logical systems. I will apply it, me and Sadegh-Zadeh will apply it to deontic logic a bit later in the presentation. So, a concrete example of fuzzy logic, heart rate. Heart rate is a numerical variable between 0 and roughly 200. But we can also transform it into a linguistic variable. So the value that can take the numerical variable heart rate is 0, 1, 2, 3, etc. until 200. And the linguistic variable heart rate can take many different values. Here is an example that I made by myself based on the American Heart Association data about adult men. We can granulate it more or have different values. It depends. It's just a tool example. So the linguistic variables can take values like bradycardia, normal, and tachycardia. And so the linguistic variable heart rate is a fuzzy set valued. It means that all the values it can take are fuzzy sets. That for any individual x with the numerical value heart rate x returns a fuzzy set such as bradycardia, normal, or tachycardia as its linguistic value. We can define how do you find the membership function of each of the different sets. And so you can say that if I have a heart rate of 50, I am part of the membership function of my heart rate to the bradycardia set is 0.5. Same for the membership value for the normal fuzzy sets. We can do many stuffs with the fuzzy variables. We can combine it. For example, another medical example, blood pressure is the combination of two values, the value of our systolic blood pressure and of diastolic blood pressure. We can combine, we can do a fuzzification, so define a linguistic variable of what is a normal systolic blood pressure, what is considered hypertension, and then combine it into a 3-dimensional graph. And based on this graph, create fuzzy sets of what is a normal general blood pressure, what is generally considered hypertension, etc., etc. So we can do a lot of stuff with fuzzy logic. It's funny. Why is it interesting to apply it to medicine? The main reason is that medicine is considered an uncertain discipline. Medical knowledge is uncertain. That's widely accepted by philosophers of medicine, by physicians themselves. There's this funny sentence of Upshur, very little in clinical medicine falls under these two categories of impossibility or certainty, except for the certainty that if someone is born, they will inevitably die. This uncertainty is caused by many different elements. One of them is the fact that many medical concepts are vague. Vague in the sense that I explained earlier of the sense of fuzzy logic, but we can also give other similar definition. So a concept is vague if it has borderline case, if it has things that are fully the concept, fully not, and a kind of borderline case of not completely the concept, but still a bit. Or this definition that I quite liked by Sadegh-Zadeh. A concept is vague if it is tolerant. A term T is tolerant if and only if an object to which it applies, a T object, is allowed to be slightly different from what it is to remain still a T object. Vagueness is a property of medical concept, but it can be seen as a bad thing. I defend that vagueness of medical concept is something that we cannot and we should not avoid. We cannot avoid it because medicine deals with highly complex systems and highly complex issues, and we are not able to do more precise for everything. But we should not avoid it because increasing the precision does not always mean increasing the relevance of the information. And because medicine has a practical goal, we want to have relevant information to do actions. So to defend this position, Sadegh-Zadeh himself uses Zadeh's principle of incompatibility. Sadegh-Zadeh and Zadeh are not the same guy. Sadegh-Zadeh is the German philosopher of medicine, Zadeh is a logician, I think also an engineer, that created that is considered as a father of fuzzy logic made by engineers, for engineers. So two different guys, but Sadegh-Zadeh is using Zadeh as an example, and he's using his work. So Zadeh's principle of incompatibility, our ability to make precise and yet significant statements about its behavior, diminishes until a threshold is reached beyond which precision and significance or relevance become almost mutually exclusive characteristics. There's this picture that if something very heavy is falling above me, and I prefer to have someone that say to me, look out, than 100 kilo mass is approaching your head at some vitesse. I don't have the word in speed. Thank you. And that's the same in medicine. For example, the notion of flu, the disease, it's a vague concept because it's related to different symptoms, to different viruses, the presence of different viruses in the body. But if someone has a patient who, if I want to say something relevant about the flu, I want to use this concept even if it's vague, because I want to know that I can, if I have, my patient has the flu, I can find what are the treatments for the flu, what are the prognosis, etc., etc. If I want to make something more precise, I either have to be very, very general or very, very precise, too general or too precise to be relevant and useful in medicine. Okay, so that's based on this argument that medicine and medical concepts are vague, that Sadegh-Zadeh is applying fuzzy logic to vagueness. But he applies it on this argument, and it doesn't really answer the question about what is the role of normativity in medicine, and so that's why I will do here, and that's what I will do here, and then I will try to continue what it does. So, what is normativity? That's really not that easy to answer to this question. It's more difficult than I thought, and because normativity is a widely used concept, a lot of people agree that medicine and medical and clinical reasoning use norms, but no one defines really clearly what they want, what they mean when they say norms. So, and even in meta-ethics and moral philosophy, there's no clear definition of what is normativity. There's absolutely no consensus. So I'm using a definition close to the one used by Parfit, but because it's not a consensus, but widely agreed one, even if it has critics, and it's a very general one. So I would say that norms are reason for action. So normativity in terms of reason, it means that norms are factors that count in favor of or against actions or attitudes. It's a very broad definition, like it's something action guiding and reasoning guiding, but I use it because it seems to fit what we want to do when we do clinical reasoning, which means having actions or how to do a sentence as conclusion of a reasoning. I also use a distinction made among others by Sylvan and Thompson between two kinds of norms. First, deontic norms, and second, evaluative norms. Deontic norms are judgment that leads to an action in the sense that it say some action ought to be done, or ought not to be done, or can be, or may be done. So basically, we'll talk about it later, but in what we call deontic logic, we have three operators: permission, obligation, and prohibition. So all sentences having this form are considered deontic norms. And evaluative norms is judgments that evaluate qualitatively, so all evaluation of something as desirable, undesirable, good or bad, better than, etc. This notion of evaluative norms is interesting because it makes the distinction because what is normal and what is normative, in the sense of what we call a statistical norm, because something that is not normal, that is statistically strange and not the norm, is not always problematic or considered as a bad thing. Having the notion of evaluative norm, we can say that something, even if it's statistically normal or if it's not, we can say that it's a problem, that it's bad, that it has to be, that we ought to do something we ought to do something. Often, an evaluative norm is implicitly deontic, because if we say the health of this patient is bad, it will imply that something must be done for this patient. So I have this distinction. It's very work in progress stuff, so I don't know if this distinction is necessary. I find it useful to make a distinction between type of norms used in medicine. I don't know if it's a necessary distinction. The sentences in light blue in my PowerPoint are questions that I'm still working on, and that I would love to have your opinion on it. So that's the definition of normativity I use for now. It's a working hypothesis of what is normativity. If you have any comments, I will be glad to have them. So, normativity in general, we have an answer. What about norms in medicine? Why is it important to talk about norms in medicine? First, because medicine is a deontic discipline. What I'm saying as something is a deontic discipline, it gives rules of actions for human behavior. It's related to the fact that goal of medicine is practical and therapeutical, especially in clinical context, because we can discuss that it's not the case in biomedical research, etc., etc. But the part that I'm interested into, so clinical context has a practical therapeutical goal. And we have this sentence by Wiseman: medicine is a normative practice because every medical intervention implies a decision about how the future of somebody should be. So there's deontic norms implied in the reasoning of clinical practice. So norms are a reason for action. Medical reasoning leads to action. We need norms in medicine. That's mostly their argument. It's, as I said earlier, it's widely accepted because everyone is saying that medicine has norms somewhere in their reasoning and in practice. But as I said, it's not very defined what they are saying when they are saying that there are norms. Even Sadegh-Zadeh himself recognized that medicine is normative, and medicine is a deontic discipline, but he doesn't go way beyond that simple assessment that medicine is a deontic discipline. So an example of concrete understanding of norms in medicine: the notion of disease is a deontic concept. It can be illustrated by this sentence by Engelhardt. It is then considered something ought to be treated and ought to be controlled. In exactly this deontic sense, the concept of disease is not descriptive but normative. It identifies what ought not to be. There's a whole debate in philosophy of medicine between normative and normativist and naturalist position about health and disease in general and diseases in particular. The point is here is not a position inside this debate. It's more like for a physician in the clinical context, even if we can describe a disease as a fully natural kind and we can describe everything about it with biological and physiological facts, the classification of something as a disease has a deontic role. That is, it has to be treated, we have to do something for the patient. There are other concepts of medicine that imply norms. Of course, diseases are the most obvious, I think. And so we have norms in medical and clinical concepts. What are the properties we want norm to have? It's the most yet unclear and not certain part of my talk. I don't know if those properties are necessary. I don't know if those properties are absolutely needed when we do medicine, so I will be very happy to have you comment about this. First, norms must be considered as relevant element for reasoning. If it's not the case, my thesis doesn't have any sense, which might be sad, but it's based on the fact that some clinical reasoning are action-oriented, and so the conclusion will be normative, at least in part, will be deontic sentence. Like prognosis and the solution of a treatment, we want to be able to say what we ought to do at the end of the treatment, what should we do with the patient. And some clinical reasoning have norm as premises to, like, for example, the fact that the physician wants to save the life of someone, and as a physician we ought to save the life of the patient if we can. That's a premise that is part of clinical reasoning, and so norms are present in clinical reasoning as premises, as conclusion. I guess it's necessary for norms to be considered as relevant. Another property, facts must be able to bear normative weight in medicine, because some facts about, especially specific facts about patient, must lead to norms. For example, if my patient is a 90-year-old lady and has a history of trouble with breath and breathing disease, that's only facts about my patient. I want it to be. The physician want to say that I ought not to do an open heart surgery to the patient because she probably die. So facts must be able to lead, must be leading to norms. Norms must also be related to the context, because the same information for different persons in different situations will not always have the same weight, will not be valued in the same way, and thus not have the same conclusion. Some medical norms are completely general. It is a sign of bad state of health to lose a lot of blood. That's right for everyone. But, for example, 45 BPM is a sign of bradycardia and thus a problem and has to be treated. It's not always a problem to have a BPM of 45 if you're, for example, a professional athlete. It's completely normal and it's okay. So the norms that will derive and arise in the reasoning should be related to the context. So we should have the possibility to do conditional norms, not just one ought not to kill someone, but conditional norm. If there is and y, etc., then one ought to do X. And last property that I have for the moment, we must be able to balance norms, to make comparison. It's based on this idea that some medical concepts are comparative. A lot of them. There's a really good article by Schroeder about how health is a intrinsically comparative concept. The idea is just we want to be able to make comparison in medicine, and we want to be able to make comparison related to norms, because if I take my patient that has the flu, I want to say that the state of health of my patient that has the flu is better than it was 2 days ago. I want to say that the symptom is more serious than this other one, so I want to do comparison between things, and comparison not between just facts, but comparison between norms that are implied. So we have a first sketch of what should norms in medical reasoning do, what should they be. Can fuzzy logic be applied, take into account those characteristics of norms? For that, I will be interested in fuzzy deontics, so that's the application of fuzzy logical systems to deontic logic. Deontic logic is just, it's model logic with the 3 model operators that I said about before, so prohibition, permission, and obligation. And Sadegh-Zadeh himself has a proposition of fuzzifying deontic logic, so using for non-deontic parts of logic, using fuzzy logic as it is, and fuzzifying the model operators, and so we can say like something is very weakly obligatory, something is strongly obligatory, etc., etc. We can fuzzify the deontic operator themselves. Sadegh-Zadeh, in his article about fuzzy deontics, is doing not fully formal logic, because he's in this engineering framework, so he wants to be able to, he wants his system to be applied by engineer. So it's not fully formalized, it has problems about how do we use it, especially the logical connective, etc., that he doesn't answer. But that's still how fuzzy deontic logic could work in a more common sense way. So with fuzzy deontics, we can create fuzzy algorithm. I created an example about blood pressure because we already had the data. So we have the variable obligation. What are the values that the obligation variable can take? It can be absent. You can have no obligation to do anything. Very weak, moderate, strong, and very strong. And then systolic and diastolic blood pressure as linguistic variable. And I took the same fuzzy set used in the precedent graphs. And then you have the variable, not the variables because they are outside, but what does it means in the algorithm? So x1 is systolic blood pressure, x2 is diastolic blood pressure, and y1 and 2 are the actions, so the conclusion, what should I do? So we have prescribing antihypertensive drug and sending the patient to the emergency, and then based on that we can build a fuzzy algorithm also based on the American Heart Association data. But what should we do when we have such and such blood pressure? If your systolic blood pressure and diastolic blood pressure if the systolic blood pressure and diastolic blood pressure of one's patient is normal, then you don't have to do anything, just let them live their own life. But if their systolic blood pressure is, in the case of severe hypertension and diastolic blood pressure the same, then the obligation to prescribe them antihypertensive drugs or sending them to the emergency is very strong. So that's how it works. It's really for engineers, it has logical problems, but that's what we could do if we want to fuzzify deontic logic. So does this fuzzy deontics take into account correctly as we wanted to do, as we wanted norms in medicine. In physiodeontics, there is a distinction between different types of norms, between deontic norms and evaluative norms. Again, the question, do we really have to make a distinction? In any way, in physiodeontics, it's clear, because deontic norms are sentences, propositions with deontic operators, so there's a clear definition of what it is. But evaluative norms are also there by the bias of linguistic variables. Because when we say that someone has a normal systolic blood pressure, we make an evaluation of what is the state of the. We make a qualitative evaluation of what is the state of their systolic blood pressure. Both are considered as relevant information in the reasoning process, and we may also say, I'm really not sure about this part, we may also say that the determination of linguistic variable is a way to take into account the context dependency of norms, because I said that the graphs that we have about systolic and diastolic blood pressure is based on on data for American men, American adult men. So we may change the data, and we may change the evaluation of the data. So it may be a way to take into account the context dependency of norms. I'm really not sure about that, but it seems that we can. Another element, fuzzy deontics, is linear. That's not only a property of fuzzy deontics, but of fuzzy logic in general. It means that all the values that variable can take is on the spectrum. For example, if we have truth value, the value will be between 0 and 1 on the spectrum. We can do a graduation of that. It's a problem for some cases of vagueness, because we don't always want this idea of linearity, but I don't think it's a problem here for the specific case of medicine, because, as I said, medicine is sometimes comparative, and so linearity facilitates the comparison. And specifically for evaluative norms, because they are the most compared norms, but also even deontic norms, if we have linearity, we can make comparison between like this, the blood pressure of this patient is less normal than the blood pressure of this patient. So it may be a good property, an interesting property for dealing with norms in medical reasoning. I've been quick. So I still have a lot of work to do. That's what I want to do later on, because I feel like I've proved that a few elements of fuzzy logic seems to be useful for medical reasoning, including the normative parts of medical and clinical reasoning. Fuzzy logic, for example, I only know about fuzzy logic for engineers. So what about fuzzy logic for philosopher? And it asks question about logical connectives, because as I said, fuzzy deontics, fuzzy algorithm with fuzzy deontics is not a good application of what should logical connectives do. So what about logical connective do in fuzzy logic made by philosophers? What about the rules of inference? Does it still work? Is it still relevant to talk about medical reasoning and about norms in medical reasoning? There are also many different systems of fuzzy logic. Is there a better fuzzy system for medicine than others? Should I choose one or not? Also fuzzy tools, because I applied it to deontic logic because I want to work on norms, but are there other logical systems that could benefit from fuzzification? I don't know, I still have to do this work. And in my most uncertain part is about the notion of norms in medicine, because I chose a definition, I have properties. Is it the good definition? Is it the good properties? Are the properties necessary? I honestly don't know, and I really have to do some research, but I will be really happy to have your comments on that. Thank you for your attention, and here is my...
Shall we take 5 or go directly to it?
Oh, let's do 5, yeah. Good time.
Yeah, 5 minutes break. So now, question, comments, when?
Yeah, I can see some similarities between our topics. So I just wondering what's the difference between the fuzzy logic and the statistic inference. Yeah, in some case we use Bayesian inference to reason from data, from information to make a decision. Yeah. On the other hand, sometimes we use statistic method to do some causal inference in test the effect of some specific medicine like antibody. So I just wondering what's the difference between the fuzzy logic and the statistics reasoning. Yeah.
Okay, this is funny. Not to say that I just hire like clones of people, but Marco online says, what's the connection between the fuzzy logic that interests you and the fact that reasoning in medicine is sometimes statistical? So, inquiring minds want to know.
Especially in the engineer version.
Yeah. There's one big difference between fuzzy logic and statistical inference, probabilistic logic. It's the fact that the membership degree is not a degree like it's not a degree of probability of, for example, if I take example of heart rate, it's not the probability of having like bradycardia or something like that. It's really but it's difficult to explain for the fuzzy part, is the fact that you are not completely part of the set, but you are kind of having bradycardia in the vague sense, and it's not the probability that you have bradycardia.
Oh, I would say just use the continuous variable in some statistic analysis. Yeah, in that case we can use from inference from sample to population.
Mm-hmm.
In here, maybe don't need like discrete variables. In some case, we can use the continuous variables, like the case you said. Yeah, maybe.
The difference is really about like which kind of variable do you use, but what does the variable mean?
Yeah.
And so I'm not sure I can answer more than that, but it's an interesting question because there's a whole probabilistic logic, which is also, I think, a many-valued logic, so with many different values that can be taken. So the two of them are not similar but close, but the meaning of what does the value mean it's there that there is a difference.
Yeah.
Blandine?
Thanks, Victoria. It was very interesting and super well explained. Did you encounter fuzzy logic and then you were like, okay, it makes a lot of sense? Or did you first thought about vagueness and did you check other logic of vagueness and you end up choosing this one? Or is there other vague logic that you would be interested in for this topic or to compare or to use in your thesis?
Thank you for the question. I really discovered fuzzy logic and the whole vagueness problem with Sadegh-Zadeh's book. So it's a big book, it's widely cited when we do like analytical or close to analytical tradition philosophy of medicine. I had to read this book because it was everywhere, and then I discovered fuzzy logic in it. So I don't know much about other logics of vagueness. It would be interesting, but for a few months ago, I worked a lot about uncertainty and vagueness, etc., and I was deriving and not doing normativity stuff and norm stuff. So I wanted to go back with this talk to go back to norms. So maybe it will be interesting, but I don't know if maybe other vague logic for vagueness could work with norms, but I wanted to refocus on fuzzy logic. Okay, that's cool, that's a great tool to talk about uncertainty in medicine, but what about norms? So
Thanks.
Kazem?
Yes, I have a question which is more of just a curious question about the fuzzy logic or fuzzy logics. I mean, you said that at least some of them were developed by engineers, so it implies that they're probably useful. I was just curious where they're used apart from Sadegh-Zadeh on this. Like, are there like major fields of application or kind of problem where they're employed, for example?
Actually, there are lots of
Yeah.
application of fuzzy logic in not only in medicine stuff, but I saw a video of a guy doing like I don't know how to say it, but like the temperature of a room. How do we deal with that? With the I don't know how to say climatization.
Air conditioning.
Air conditioner. Okay, so doing air conditioner algorithm for air conditioner. Or when does it have to be to send warm? When does it have to send cold? So it's applied in a very different field in engineering, and it's a point that I didn't include in my talk, but the idea that medicine and that Sadegh-Zadeh is using the engineering explanation of fuzzy logic is not completely strange, even if he's a philosopher, because medicine can be and is by Sadegh-Zadeh justified as an engineering science. Like, we want to apply science and scientific stuff to concrete situation, in the case of medicine, human. But so it's not that crazy that he used fuzzy logic for medical context.
Just to add a small thing, for a lot of quality evaluation of products, when you do some automatic system, it's often under the hood that the algorithm looks like fuzzy logic. A lot of them, a lot. But so often they don't call it fuzzy logic.
No?
Yeah.
The engineer.
Well,
They use other words.
some don't like it, but there's.
I think the word fuzzy.
I was gonna say, that's gotta give some people allergies, right? The idea that, oh, my reasoning's not fuzzy, what do you mean?
Yeah. I do an evaluation of the product.
Yeah, in engineering talks, there are a lot of, like, you have fuzzy parts, but you have this defuzzification parts. So we don't
Yeah.
always, everything is not fuzzy.
So I have a finger on better. So it's also related to Ben's talk. Question. So I think that that the interesting applications in engineering have always to do with the interface between man and machine, because we use words like bradycardia and not the continuous variables. We don't use blood pressure, and that number would be useful for us. You need a word like that, and so even if we deal with air conditioning or whatever, we always want to like steer the machine in some direction that is compatible with our language. Given that our language is fuzzy, the easiest engineering trick to do that is by using some kind of a function in the real interval. So it's not really a question, it's like a remark. I also have questions, but I'll leave my questions to the end. But then, and it's being used more broadly, where people also try to do the actual engineering, not with precise continuous variables, but with some kind of fuzzy logic. But then it's more questionable whether it's actually doing useful work if it has nothing to do with our language. That is by definition vague. You could really wonder whether you don't lose some information when going from heart rates to something vague like bradycardia, even for deontic stuff, and that's maybe leading to a question that we could handle later.
Ask it, okay? Just ask it now.
Yeah, but I don't want to like.
No.
This is just like even in cases of if the logic is completely, if the framework is really if medical science would become a perfect or something, in the sense that we know perfectly well when to treat somebody with a certain heart rate, and we have a nice sort of set of algorithms that maybe are even generated by AIs and so on, that say if we have these parameters, then we have to do these actions. It will still remain a normative discipline, because in the end somebody will have to act on the basis of that. But you could imagine that behind that, in the computer or the person that makes those decisions, that it's a perfectly non-fuzzy thing that's going on. You go from continuous variables and Bayesian reasoning to an action that is either do it or not, treat the patient this way or not, or this way or this way or this way. I mean, that's like, there doesn't have to be intuitively anything fuzzy going on if we are not dealing with human language, or at least that would be my intuition. Would you agree, or would you think that no, that's actually a mistake, that we can go this precise, that at some point we get rid of the fuzziness? Is the fuzziness going further than just the language being imperfect and human? That's, I guess, my question.
That's a really good question, and I don't have a definite answer to that. Because it's really unclear. Some people say that we will never have, even with personalized medicine, etc., we will never have non-fuzzy understanding of medicine and completely precise and clear, and that disease, for example, disease is intrinsically a fuzzy concept, and that cannot and should not be defuzzified and precise. I honestly don't know, because as human, I don't think we could completely understand everything about, but maybe with AI or an imaginary thing that
But
could understand.
But you don't need to understand. It's just that if Peter is right, all your norm will be evaluative norm. But maybe there's other kind of norms in medicine. It's which one could be defuzzy and which one are robust.
Which one in norms?
In
Which
the norms,
norms?
in
Okay.
the norms. And if some norms are impossible to defuzz, that was a nice word. Defuzzification.
Defuzzification, yeah.
They would be different, okay? But maybe for a lot of diagnostic algorithm, it's just evaluative norm. Maybe. But some like health,
Yeah.
disease, I don't see it easily how we could get rid of the fuzzification.
Yeah.
But it's maybe not all norms, yeah.
You call those evaluative?
Yeah, it's because maybe I don't understand what it means.
Yeah, it seems like the kind of thing that you would never get rid of, even if a computer does the basic diagnostic thing, is the last step that the computer says, treat the patient, do this, and that's a really directly deontic norm. And those we will not get rid of.
But I don't think you will I think I agree with Alexandre. I don't think you would get rid of the evaluative, because even if you have extremely precise understanding of the state of your patient and extremely precise data, you will have to say that it's, even if you know exactly what is happening, etc., you have to say that it's a bad condition, that it's a disease, so you will have to evaluate it, even if it's not fuzzy.
Mm-hmm. Yeah, I guess. Yeah, I think that's a good point. Yeah. So also the evaluative probably cannot be gotten rid of. But the deontic definitely not.
But your question was not about norms. It was about, can we get rid of fuzzy?
Yeah.
Okay.
Yeah.
Yeah, for that I have even more work in progress hypothesis, and we talked about it, that maybe we should keep medicine fuzzy. Maybe if it's even if it's not intrinsically metaphysically fuzzy, but because fuzziness can help us make decision more quick, faster, or it's easier to say that this person has the flu, so we have to give them antibiotics. Then it's faster than being sure about all the symptoms, all the presence of the virus, and etc. I think fuzziness is still an interesting feature of medicine.
And the fuzzy word here would be, or for the adjective, would be having a flu.
Yeah.
Is that a clear case of a fuzzy notion? Because like it's clearly vague, but
He's having a bad flu.
Can you,
That's
like,
automatically fuzzy.
the flu is like a real virus, so it's like just a bad flu would be
Bad flu,
a clear thing.
something that you have to act.
But having a flu, you could still like give then a precise definition. It's not everything is vague in the end, but in human language. But it's not a prototype case where physiologic would do a real good job.
No, it's not a prototype case, but could we really have a clear definition of what is a flu? Because you can be have the virus and be asymptomatic. Do you all still have the flu? If we consider that the flu is a disease, and so if we say someone has the flu, someone has to be treated. If someone is asymptomatic, they don't have to go to the physician and they don't have to be treated. So
Yeah. No, it's probably also the number of the viruses and so on. If there's just one like individual in there, you probably won't call the patient having the flu. So indeed there will be, but it's an interesting case because I don't think it's like easy to give values between 0 and 1 on having the flu.
no, clearly not.
So it's a clear case of vagueness, but unlike bradycardia, it's a much more rich and non-scalar vague property, it seems.
Yeah,
Having the
fair
flu.
point. Yeah.
As that and Jonathan, as that first.
Yes. I was just thinking that medicine uses a lot of vague concepts, some of which can be fuzzified, etc., etc., etc. And I was just curious, like, what sort of why it's so. Why should we use fuzziness in there? Just because they're vague concepts, it's in the end will be tied to this question of normativity, or that we need to have, I don't know, some deontic judgment, something like this. Because I was thinking about other sciences which use a lot of vague and possibly falsifiable concepts, like, in biology. If you use non-mathematical description, arguably there is a lot of vague and fuzzy concepts. So I don't know, in many other sciences like geology, geography, everywhere, the people where they use categorization, it seems that in theory you could fuzzify all of this. It's like, will it be still as useful as, for example, in medicine?
In other disciplines.
Yeah, I was just curious, like, whether is there something specific in medicine which makes it so sort of a good target for applying fuzzy logic? Apart from, I mean, you already said that it's the fact that it's a bit like engineering in the sense that it's sort of practical discipline, which should end up with sort of practical guidelines. But is there something else, or?
It's a good example of a discipline that can be falsified because it's widely accepted that it's uncertain. It's probably not the only one that could be falsified, but there's this, and Peter's question is make me wondering if maybe it's not that of a good case. The idea of linearity, I don't know, where is the slide? I'm not familiar with other disciplines, but if you have vague concept but that cannot be falsified because you don't have this idea of But maybe the flu is a good example. Like it's vague, but could we always say that someone has a flu to the extent, I don't know, any membership value? It's not the case. So if linearity is interesting, for example, then it's the case for blood pressure or heart rate, etc. It's fuzzy logic is a good tool for anything inside medicine or outside medicine. But if your concept cannot benefit linearity, it's probably not a good thing to apply fuzzy logic, because linearity is fuzzy logic is an answer to the vagueness problem, and linearity is one of its specific properties that are criticized. So there are other ways of dealing with vagueness without this idea of linearity. So I suppose if your discipline cannot allow the idea of linearity, it's not a good candidate. And maybe medicine is not that of a good candidate for something like the flu.
Some part at least it is.
Yeah.
So that's enough to make it interesting for
Yeah.
application.
My question is regarding the object that is falling. Thanks a lot. So does fuzziness really allow to be more reactive, to be more quick? And why does fuzziness allow you to be more reactive? Is it because you have vague set that you can put more stuff in it, so the word that's coming quicker, you have more word to say about something? Or, because if you check over there, the element that is falling, you could say, be careful, an element. Is it fuzzy then? It's not, but it's quick too. I don't see the link between fuzziness and being quick at saying something, except maybe that you can say more stuff with one word, and so you go quicker to one word that is described by it. I don't know if it's clear, sorry, but...
I think it's clear. So this example is not an example of, I don't think lookout is something fuzzy, but it's something that is significant. And I think that fuzziness but vagueness in general can be not quicker, but more significant than precise data. Because saying that, taking back the same example, but saying that someone has a heart rate of 40, it's not fuzzy, it's data, but it doesn't say that much about the patient. You have one information about the patient. Saying that someone has bradycardia is more fuzzy, but it says something about their heart rate, but also about their general state of health, the fact that they're probably not professional athletes. So fuzziness can be more significant because it gives you more information that you could probably have if it's a patient you could probably know that it's not a professional athlete, etc., etc. But just in one information in one sentence or proposition, you have more information about the general context in medicine, in the case of medicine specifically.
Which make it quicker then.
Yeah.
Okay, nice, thanks.
This follow up on that? That was something that I was thinking of as you were responding to some of the questions earlier. Is how to put it. It's not clear to me that it's the fuzziness itself that's doing that work, right? It almost seems to me like what you're arguing for is there's this set of medical concepts. They have lots of features. They're normatively loaded. They come with all this extra information packed in. By the way, they're also fuzzy.
Mm-hmm.
But those concepts just prove to be way more useful when you're trying to have medical interactions than here's a really long list of very precise data points.
Mm-hmm.
Part of that I guess might be traced directly to the fuzziness, but it seems to me like a lot of that usefulness, just as came out in that answer, right? A lot of that usefulness is also coming from these other things that are packed into the concept as well. Including in some cases, it seems to me like the very fact, this is also a good thing for your argument, the very fact that the concepts are normative is like doing something for you here, right? I mean, part of why it's useful to say the flu, that somebody's got the flu is that you want to make the evaluative judgment, right? You want to say, like, oh yeah, and you know, as opposed to, I don't know, someone who's just really, really, really out of shape or something. I don't know, I'm trying to think about like what would give you the same kinds of symptoms, like you're short of breath all the time and there's nothing we can do about it. Like, we're very sorry. So I mean, maybe there's something to be said here for a kind of broader analysis of medical concepts, which is, I mean, not a very helpful thing to say, because that's like really, really hard.
It's really hard, but it's what I will do, because fuzzy logic is an example of a logical system that may be applied to medicine, but I want to discover and explore the cases of other logical systems.
Good.
So it's a good way to have in mind that maybe we don't necessarily have to keep fuzziness. We just have to keep norms, and it may be sufficient.
Good.
I have a finger on that. So the example, the nice graphical thing there is of course confusing. Because it makes it too easy, the problem, and that's, I guess, also the confusion, Blondine. Of course, like, precision also can mean being completely, having all the precise numbers, could be weight, could be what you call precision. Of course, that takes a lot of time to communicate that, and a lot of useless information. But you can also be very general with non-fuzzy words that you would not call precise maybe, but the terms themselves are defined in a precise way. So you could say there is an element, there is something falling is perfectly precise, well, to the extent that it doesn't use words that are vague. But it's not precise in the sense that you have to give a weight or something like that. And in the same sense, we can also have these normative words like the cardias. I forget the precise words. Medicine is not my strength. The descriptions for the kind of cardias.
Bradycardia?
Bradycardia, for example. That word is fuzzy in practice, but you could replace that by a word with sharp cutoff, like from that point to that point, the person is called, and can then still have a normative consequences, right? It seems to me, and it would be super imprecise if you say that somebody has bradycardia, but not because of any fuzziness, but just because you have not said much about that patient, except that it probably should have some kind of treatment or something like that. So the question of whether we have sharp borders seems for pure action not directly hindering or something like that. We need very broad categories, but we can still have the frontiers, the limits between them perfectly sharp. That's at least in principle a possibility. But there seems to be something problematic with that, right? To say that flu is exactly between these and these borders, or bradycardia is exactly between these and these. And so there's another element, it seems, that plays like in the difficulty of finding such a definition, such that it's normatively useful. So do you have any ideas on how to go a little bit further in that problematicness of defining the borders, even in very imprecise cases? The word precise is dangerous here. Do you agree with that? That's my first question. And if you do agree, like how to go a bit further?
The word precise as problematic, maybe I agree if we say that like precision as the opposite of fuzzy, it's a problem because it's not the case. I'm not sure I fully agree that precision is a problem in general, but in the case of medicine,
you can have too much information, can be a problem for action, right?
Of course, in the case of medicine, precision is not what we are looking for because it may be too much information and so we lose time, etc., etc. But also, and it's more related to, not to clinical reasoning, but more to the production of medical knowledge. If we want to have generalizable knowledge, we cannot be too precise. Because if we are, we cannot, like if we have precise border of what is bradycardia, etc., etc., we will have to define like different bradycardia for different type of patient, like men between 40 and 50 that are ex-professional athletes. That's the precise the border of bradycardia, but it's not the same if it's a woman, if it's like 10 years later. So precision is
but
that's useful, no?
But Victoria, imagine a deep learning system. So you take a lot of diagnose made by human with their fuzzy logic. The system will give you precise border for these class. Maybe not explicitly, but in the weight and the neural network, they will be there.
But if we are biased, like we give knowledge to the...
Yeah, but anyway, everything is biased all the
but
time.
then we would have still not clear borders. Because we would have some form of...
But the system will give you clear borders. Maybe you won't...
Is it right? Then?
Yeah, but there's no right here because...
Maybe not.
There's no right. Bradycardia does not exist independently of us in the world. Okay, that's a normative concept. So I'm not saying the machine will be better or worse than us, but it will provide some kind of borders to something that we cannot by ourselves provide borders. Is it a good thing? That's different. And that's my question to you and to complement the question of Peter. Would it be good medicine or not?
I might be biased because I'm working on medical reasoning made by human physicians. So I don't have an answer because for human physician, it's probably a bad thing because it's lack of time, etc., etc. I don't have a definite answer in the case of deep learning, AI, physician, etc., etc. I don't know.
Because that's the goal of deep learning and diagnose. It's to put borders where we cannot. Based on millions and millions and millions of cases that are treated in a fuzzy way by humans. But after that, I don't know, it's a good thing.
I don't know either. I don't have an answer.
I don't trust doctors in general. I don't know why we put our lives in the hand of these completely bourgeois biased people.
But we do, we have no choice.
We have no choice. We have no choice to trust their judgment. I don't say their knowledge, not to trust their judgment, the part that is fuzzy. Exactly. Because their knowledge, I'm okay. They did the exam, they're okay. But their judgment?
Yeah. Except if you take into account the fact that most physicians do reasoning not really based on their knowledge, but on their judgment. Like it's proven that
Experience
expertise and
and
experience is mostly what physician relies on when
of course.
doing
Absolutely.
physician.
That's why I'm skeptical.
One more question online from Marco. In recent years, we've been hearing more and more about precision medicine. So how does precision medicine relate to discussions about fuzziness?
What is precision medicine?
Precision of personalized medicine
Oh,
is
personalized.
yeah.
Okay.
It's actually a good question, and I don't have a clear answer, but often philosophers of medicine are chilly when talking about precision medicine because it seems that the problems like fuzziness, vagueness, etc. are less a problem, but it's still a problem because if I have a flu and 2 years later I have a flu, it's the same person, it may be not the exact same disease, and so the problem is just not on the same scale, but the problem persists. But again, if we have AI physician, maybe the problem of precision is not a problem anymore. But in the case of personalized medicine made by a physician, I think the problem is just you avoid many cases of going from general and populational knowledge to individual, but you still may have cases of vague case, because if I'm taking myself now, and in 50 years maybe the same data will not give the same results as, for example, having a disease, having a hypertension, etc.
Okay. Can you elaborate a little bit more about one of your properties? The fact must be able to bear normative weight. Can you explain better that, or because I didn't understand?
This property, no, this one, not this one. Okay, this property is there because in normativity literature there is this debate about the distinction between facts and norms. And I honestly don't know what to do with this distinction, but at least I can say that if we make a distinction, it should not be a full dichotomy. Like there must be relation between them. But
why are you saying that? I agree, but based on what?
Because you can have clinical reasoning that based on facts and facts only, and not lead to a normative conclusion. So there has to be
How? Because or you attack the distinction, just to structure my question to be more precise, or you attack the distinction based on, Putnam language makes no sense, bullshit, never existed. Okay. It's an invention of philosopher, facts, norm. Or you based it on, I can induce from facts norms or something like that. Not deduce, of course, but induce or something like that. So in the way we reason, we pass from one to the other. But here it seems that a big part of your project is quite to separate the thing, because using fuzzy logic seems to me a good way to separate factual from the normative. So
why?
Because you take under control what is normative. It's related to the vagueness.
But
the factual
facts,
part, it's the measure, the heart, the things,
but
it's the data, what you call the data. That's the factual part, or maybe I misunderstood.
I'm not sure there's that much of a distinction, like normative parts is fuzzy and facts are not, because saying that someone is young, it's a fact.
ask me. I have no intuition in logic. Okay. Probably it's a fact,
Yeah.
but it's a normative fact. That's what you want to say. It's the way you understand bare normative way. Because I was very struck by this expression. It's
Honestly, I just took it from, I think, Parfit somewhere
okay.
to just
okay.
say that facts, I think he says like facts are or can be normative and let's say can bear normative weights to just still make a distinction and don't create a whole debate about the facts versus. Yeah, but I'm really not sure about this distinction because if there is nothing common between facts and norms, how can you go by making reasoning from one to another? It's just an intuition, but intuitively it doesn't seem right if there's nothing in common. So yeah, that's.
But is there nothing in common? Is it the same thing? That's what I'm asking you for you.
I don't know. The only thing I know is that's not a full dichotomy in a Plumwood sense. Like there's nothing in common and they're fully separated. The only thing I'm quite sure is that it's not a dichotomy in Plumwood sense. After that, is it the same thing? Is it part of? Does it have like normative weights on facts, etc.? That's a question I still have, and I'm working on it. I don't know, but the only thing I think I'm sure of is it's not a full dichotomy.
Okay. Fair enough.
But it could be a perfect dichotomy, and still you can use factual information to get to a norm. For example, if your norm is I have to prevent killing from happening or something like that, the fact that you know that some killing is about to happen, you know that you have a duty to stop it. So that can be more general norms or values or whatever, more general obligations or I don't know, virtues or something like that, whether you're Kantian or virtue ethicist or something like general principles that bring you from factual information to norms, even if you have a sharp one, it seems.
Yeah, but there seems to be something, because if you just know that something is, if you just use facts like someone's about to kill someone, and you just know that, how could you infer that you have to...
No, you need a general principle, that's why I refer to it. So if you have a general principle, I have to prevent murders from happening or something like that. And that could be a virtue ethics thing or a deontic, like a Kantian principle or something. Then, given that this general principle is there is a way for you to go from something as bad as somebody's going to get killed if I don't intervene, and so I have to intervene.
It produce a normative action, not the norm itself.
Well, that's
But that's a tough.
it produces the norm, not to have to intervene.
Maybe a better example is the one, natural selection. Natural selection put us in the animal realm, so it's fact. But this fact, because all our ethics is based on our community, it almost forces you to think, okay, do I have to expand the moral community? So that would be an example. We're purely factual, it's factual, we just passed, we learn now that we are part of the animal realms. But it almost forces us, but not deductively, it's not force us completely, but it's a strong induction to think about the expansion of the norm to the animals. Maybe still not
some bridge principle.
Yeah, there's still a bridge principle. So
but the bridge principle is there. I mean, that we use that sort of reasoning. We use we should generalize our norms or something to other.
Or or you say, okay, but no, still, because you want to keep the distinction.
No. I'm just saying that you could have a distinction and still go from fact to norm with a guiding principle. Bridge principle. There is no logical impossibility. I mean, it's not an argument against separation.
Mm-hmm.
There's other very good arguments against separation, but not that one, I think.
Okay.
Not based on reasoning, yeah.
Okay, I suppose I have to read about that and learn about that.
Be careful, if you read about this literature, you won't believe in data anymore. Data are normative too. Putnam will convince you that data are not facts. Oh, that.
I have a short comment on this one. It seems to me that I don't see why we should go to like from facts to norms, because maybe I misunderstood what you said, Victoria. I thought that what's sort of important for you is that you can go from facts to normative judgment, and this is something like this example will fit perfectly. Like we have general normative principle plus fact. We go make normative judgment. Someone ought to do something, but I don't know if you're interested in going to norms. But this was sort of comment, and I have a question, which is, so when you said that there is like normative stuff in medicine, I just thought about it, and I have, for the first time, I have this idea that, okay, in medicine, you actually have two types of normative stuff. First is that when you say something like, there is a patient, and you use normative concepts saying like, oh, he's in good health, or no, they're in bad health, or they have disease, something like this. And second, there's this stuff, for example, what a medical practitioner should do, or shouldn't do, or can do, or they evaluate the effectiveness of a procedure, or something like this. Do you think it makes sense to separate these two sort of kinds of normativity, or in the end it will be one the same, or?
It's the question I had when making a difference between deontic norms and deontic normative judgment and evaluative judgment. Oh, okay. It's exactly the question that and I really honestly don't know if I have to make a difference, because it seems to be different type of judgment, but couldn't we reduce one to another, or do we really need both? I honestly don't know. I don't find it. I don't know if this distinction is needed or not.
But it will be largely something like the deontic norms will be on the side of medical practitioner, the actor, and the evaluative will be evaluation of an patient or something like this, right? Or like sort of how this sort of, what I was thinking about, like the distinction of sort of when the subject of our normative judgment is the patient, and second is when it's sort of practical judgment of what an agent has or doesn't have to do.
It's an interesting. It's interesting, but I think there could be deontic norms made by patient. Like I ought to go to the physician.
Yes.
So maybe that's an interesting distinction, but I don't think it's that clear.
Yeah, but why I'm asking this question is that, for example, I was again thinking of comparing medicine to other fields, and it seems to me that, for example, in biology, you can make, I mean, not everyone will agree, but you can make a case that there's some sort of normativity, that it will be only as a sort of, it won't be a normativity in this sort of agent sense, it will be normativity in the sense when we say, oh, it's a healthy plant or it's not a healthy plant. And then if you take a field like something like, I don't know, agrotechnology, it will be something like medicine, where you have both kind of normativity, but then if you go to the, I don't know, I'm just thinking whether it's possible, I think in some kind of engineering, maybe you will have, like when you have only norms which guide actions, but maybe no sort of evaluative norms, I'm not sure, or less. I don't know, like you are not, We're not talking about healthy buildings. I know that some people do that. It seems to me that at least it's.
Yeah, but we talk about things not working the way we want them
Yes.
to work. Like it's defectuous.
Yes,
The
yes,
quality
yes.
product
Yeah, quality,
example, it's exactly
defective,
like that. It's
well-built,
that there's
yes.
clear cases, completely malfunction, and a lot of fuzzy cases. What going out of the plant is it conform to certain norm, blah blah blah, and they use fuzzy logic. And a lot of probability and likelihood calculation. It's not that far from health.
Yeah, it's not very different.
Peter?
Okay, somebody else, I don't want to. But the first finger on this one. So there seems to be something interesting here where indeed there is some kind of an idea that maybe some sort of engineering could be done that is almost language independent, like we know what we want to do, and there's just like one engineer doing it, or like being in the boss of the system, and she doesn't have to communicate her findings or anything. It doesn't talk with clients or anything. It's really just making the process do what it's supposed to do in the best way possible, and there are clear like pre-made norms for that. And the normativity is then sort of very non-linguistic, it seems. It's still normative in the sense that the machine has to do it the right way, not healthy, but it's like there's pre-made measurements, and this is a good product and this is not a good product, and the engineer has to make the product good, but not in a fuzzy sense of the word, but like it has to go as far as high as possible in this measure, in this variable. That seems to be a kind of interesting kind of a normativity, and maybe you're referring to that kind of cases as this special case. And then there's a case where you really are, where everything is about, like finally it's the patient who decides about their own life, and it's the act of communication is finally where everything happens. I mean, in the real medicine, this is probably not the case, but in an ideal medicine, the physician never has the obligation to do the treatment. She has the obligation to communicate to the patient that this would be the patient that, according to them, would be the best for, and then the patient decides, right? But then the whole deontic action is linguistic, right?
Mm-hmm.
I mean, that's my intuition at least. And so the norms are basically guiding language and talking about possible treatments. And the patient that actually says yes or no. So the normativity in these cases where language is not just like a phenomenon, a tool that we use to make it work, but where the basic action is linguistic, the physician's action is first of all like proposing treatment and then receiving an answer. Would this deeply linguistic character of the normativity for medicine make medicine special? And other
Compared to other
engineering-
speech acts, or it's what you have in mind?
Yeah,
Compared to promise and things like that?
sure. But so the case where you have actions that are really like, should I shut down this specific system, or should I repair that one, or something like that? These are actions, or norms for actions. But it's not an interaction with the human. In the case of medicine and a customer involved engineer, it is fundamentally in the language that the real action is. You propose the therapy, then you also execute it, but first of all you have to propose it in words, in human words, in fuzzy human words. It seems that the normativity is much more embedded here, or the linguistic nature of the normativity is much deeper than the case of an engineer that just has to make the right kind of product come out and does not have to talk to people about it. Yeah.
I don't know if there is a specific question, but I suppose it depends to the notion of what is ideal medicine. What is it? Because I suppose you could find physician for whom medicine should be fully engineered and not asking for what the patient do, and so not linguistically embedded. Like a physician is just supposed to heal someone and just don't take into account like the fact that.
But it's not the case in our countries, at least.
Yeah, and it seems to have a big impact, or maybe not. Maybe you don't agree, but it seems to me that if language is so important, and to some people maybe not, then the whole normativity of the fuzziness is going to change a lot. Mm-hmm. If it doesn't matter, think of the case of the air conditioning, for example. Why it's so important to have variables like hot and cold and intermediate temperature and so on is because finally these are tools that are supposed to be user-friendly, and we use words like hot and so on. Otherwise it could work perfectly without it, but it's us who steer the thing. And a sort of perfect medical doctor who just has to do the intervention, which could also be in terms of, I guess in an idealized medicine could also be just all just continuous variables, and I have to put that thing over there and that and to this point and so on, and it all has to depend on the measurements they do with continuous variables, and the whole, it cannot be a full calculation that never involves any language at all, right? It seems that if it's important to talk to the patient, everything changes, it seems to be, but maybe not, maybe you disagree. It seems that the fuzziness then is unavoidable, because I have to communicate whether my patient has the flu. I don't have to just like see whether I should give antibiotics or not. That could be a perfectly class of Bayesian kind of reasoning to decide that, whether you should give antibiotics. That would be stupid for flu, but antiviral medicine or something like that. That there's no fuzziness like involved. But if I have to tell the patient that they have a flu, then all of a sudden, like this linguistic aspect is normatively unavoidable. So for me, this seems to play a big role, whether medicine has this linguistic purpose too, in its normativity.
It's even worse because you add the notion of epistemic injustice, so there's even a more complicated normativity than just diagnostic.
That's
in the exchange between the patient and the doctor.
Yeah. That is indeed an extra aspect.
But that's a normative, interesting case.
Yeah, clearly.
Epistemic injustice between the two.
And the fact that communication and language in itself is fuzzy, like if you can just when you communicate, you have to use fuzzy terms. So here,
Yeah, the doctor cannot just provide, this is a
Yeah.
table of the data. I recommend X. Well,
Exactly.
I don't know if I have to answer that. I just take
No,
the
it's
points and
it's
no, but I can guarantee you, if you manage to introduce in your dissertation something about epistemic injustice, you will have such a better chance to get a postdoc job in life. Because that's a hot issue in medicine and in exchange, and it's important anyway. Doctor, do not trust patient.
I actually learned, thanks to your talk, that indeed there is such a deep connection between fuzziness and normativity. I never realized that it's like words like young. If that you just gave that example, like that's like a factual. But then you could say, nah, is that really factual? Why we call somebody young and not just between that and that age? It seems to do with social norms. And probably there's a lot of cases where we use fuzzy language, clearly fuzzy language, or vague language, that the normativity like is hidden in the fuzziness, and I never made that connection. So for me, it was never so clear. So thanks a lot for that.
Other questions, comment? Yeah, maybe the last one. The argument for linearity was a little bit weird. It was between, okay, it's linear because you have to compare between, there was some social aspect, the way you were talking about doctors, they have to, no, there was something cognitive about human cognition. So it's, you would choosing linearity because it has to be compared.
Linearity and comparison is not the same. Just
No,
linearity
but why
makes it.
why would you choosing linearity? You
It's
said, oh, I will state linear for blah blah blah, and I completely misunderstood what was the blah blah blah. Okay, maybe I was very confused. Because it's a choice to have linear.
Yeah, it's a choice made by fuzzy logic.
Yeah. But why should we stick to it?
I don't say that we should stick to it.
It's just to
I-
keep fuzzy logic.
I state that fuzzy logic has this property, and this property could be useful to make comparison.
Okay.
It's not necessary, but it's easier to compare something if it's on the same spectrum than
But easier for who? For us? For a machine?
probably for
I mean, yes. If I do a deep learning system, and maybe the automatic graduation will not be linear, because the machine will choose what is more efficient. But for us, I can understand.
Yeah.
For us, if it's non-linear, it's so complicated.
Yeah, maybe
We
it's
don't
still,
have any intuition. It's very tough.
yeah, maybe it's still my bias for human physician. I don't know
But
enough.
that was the point, because I was always during your talk, are you trying to modelize what doctors are doing or what medicine could be? Okay.
For the moment, it's what physicians are doing.
Okay.
Human physicians are doing.
So they would choose linearity.
Yeah, because it's easier.
Maybe the word linear could be a confusion here. It's not that as it's used in physics or something, it's really just the comparability.
Yeah, but it's
That's what
it's
linear-
under the real.
Yeah, the
It's
fact
under
that
real.
you can compare each to truth value to. Well, truth values, that was also like a criticism we have So it's not in fuzzy set theory, strictly speaking, it's not truth values. It's grades of membership. And so the truth value, it then becomes real logic, and it's not just a set theory. But independent of that, so it's just like whether they fit on a line, that's linearity in that literature.
But you could imagine that even if you think it's a line, there's some weight on this line that makes the judgment, some attractor. You go more rapidly to the conclusion in certain region of the line.
Yeah, and that's all. You can all do that with standard fuzzy logic.
Okay.
Just the fact that you have the 0-1 interval, and you can in principle compare every 2 points, or even if it's another interval of truth values, but you can compare every truth value, then that's gonna be. But there's also lattices that are like very complex in other logics, but then not fuzzy logic. Fuzzy logic like sticks to that
To the
0-1 interval,
to
but
the real.
could be any. Doesn't even have to be the real numbers. You have like algebraic semantics that don't specify that, but whatever semantics there is, it's always going to be such that every two are comparable.
Okay.
That might be useful, but of course there's a comparison possible too if you cannot compare each two elements. So if you have like 5 values or something, 0, 1, and then 3 values that are equally like in the middle, but they are different in some way, like they are incomparable among each other or something like that, then you can still compare 0 to the middle value and the middle value to 1, just that there's several kinds of being in the middle. So maybe a flue would be something like that, where there's clear cases and then things in the middle that are incomparable, how much flue-like they are. And that might also apply to medicine. So I also wanted to remark that maybe, that it's not because you want comparability that you have to make everything comparable. And that would be forcing you to go to fuzzy logic. There might still be other options.
Of course.
Okay, so let's thank our speaker.